Yeah, hi. Let's start the new lesson with the square root. Okay, so we're going to do the square root today, and I'm going to show you two methods. Okay, so let's start the both methods. So our first method is named. So our first method is named as perfect square root method. Okay, so basically it does all the square roots if your answer is not in decimal. Okay, like suppose if you are finding square root of 676, so which is 26. If you're finding the square root of 476, which is 24. Sorry, if you're finding the square root of 576, which is 24. So like this. Okay, so if you see there is no decimal, right? Correct. So this all can be done by this perfect square root method. And the second method which I'm going to tell you is called duplex method. Duplex method. In the square chapter we have done the duplex, right? So we are going to use that duplex again, okay, here to solve the sums. So let's see this first method first. So for telling you the perfect square root method, what we have to do, first we have to basically see the table of the squaring, which we have already seen, right? In the previous we have found actually the squaring. So that table I'm writing. So 1 square is 1, 2 square is 4, 3 square is equal to 9, then we have 4 square is equal to 16, 5 square is equal to 25, then 6 square is equal to 36, then 7 square is equal to 49, right? Then we have uh, 8 square is equal to 64, 9 square is equal to 81. Okay, so why I'm writing all this table, because uh, we have to use the last digit number, like you see 1, 4, 9, 6, 5, 6, 9, then 4 and 1. So these are the numbers we are choosing. Okay, so if you see 1 is at two places, here and here, right? If 1 is coming in the last digit, so then square root will be, if 1 is, if 1 is in the last digit, okay, then the square root for that number will be 1, either 1 as we have seen this one, and then or you can use 9. Okay, there are two options. Okay, now let's go for another number 4. If it is 4, then again there are two options, 4, this one, and if you can see this one also, right? 64 is there, 4 is there, so we have option of 2 and 8, option of 2 and 8. In a similar way, if you see other number like suppose 9, you can see the 9, 3 and 7, the option of 3 and 7. If you see 6, for 6 we have 4 and 6 is the option. So 6, 4 and 6. Okay, now uh, so so next we will see for 5. If you have 5, then we have last digit as 5. Okay, now what is left? 9 is done. Okay, almost all done. So these things I'm going to use for doing the sums. Okay, like as I said, right, if you remember, I said root of 576 is equal to 24, right? I said correct. Why? Let's see how. Okay, so what we'll do, uh, we'll write 576 in this way. We'll first we'll make the pair. We'll make the pair of two digits. First we'll make the 76 as a pair, and then second pair is 5. Always remember, in the Vedic maths method, pairing is always done from right side. Okay, so for 5, if you see there's one option. So okay, sorry, for 5 you will see in this table that where is 5, or the number before 5. So the number before 5 is here 1. So this 4, one number is there for 4. So we'll see that what is the square root of this 4, which is 2, right? So we'll write 2 for this, and then we will search for 76. 76 in the second pair, right pair, we'll see the number, last digit number 6 of the 76, and we'll come to this position. Okay, you see, if the last digit is 6, then we have two options, 4 and 6, right? So write either 4 or 6. Okay, so our answer can be either 24 or 26. Okay, right? Clear? So means uh, what is the what are the steps? I'm just writing this. First step is that we have to make the pairing. Then in the first pair, the left pair, we have to see the table, and we have to search the number before what is that number whose perfect square root is there. We have to find that. And in the second go, we have to see the last pair. In the last pair, we have to see the last digit, and by seeing the last digit, we have to choose from this thing, okay, which I'm circling, this thing. So then you might have two options. Then we have to select the any one, okay, because both will be not the answer, obviously. Any one will be correct, okay. So which one will be correct, which one will not be correct? I'm going to do a method call. I'm going to do it by a method called uh, this method is named as digit sum method, okay. So let me rub this, and I'm doing that digit sum method. You can write it down, digit sum method, for selecting the answer, okay. So as we have seen that 24 square can be 576, or 26 square can be 576. There were two options, right? Any one is correct. So first we will find the digit sum of 576, which is 5 plus 7 plus 6, which is 5 plus 7 12, 12 plus 6 18. 18 means 1 plus 8, again 9. So the digit sum is 9. Okay. Now we'll find the digit sum of 24 square. How to find this? So we'll do 2 plus 4 whole square, means this 2 and 4 will be added. Again this is 6 square, which is 36. Again this 36 is added, 3 plus 6, which is 9. See, 9 is coming, right, in case of 24. So obviously 24 is the answer, but let's check for 26 also. 26 square is equal to 2 plus 6, 8 square. 8 square is 64. 64 means 6 plus 4, which is 10. 10 means 1 plus 0. 1 plus 0 means 1, right? The digit sum is 1. Obviously this is not the option, okay, this option is wrong. Now we have the correct answer, 24. So 24 square is equal to 576, or you can say square root of 576 is equals to 24, okay. This is how we'll find this, okay. We can have another example, like suppose you are doing 961, right? So we'll make the pair of 61 and 9. Then we will search for the 9 from the table, as 9 is the number whose perfect square is 3, so I'll write 3. And then we have 61. So in this 61 we'll choose the options. We'll see the last digit of 61, which is 1. So 1 has two options, 1 and 9, right? Correct. So 1 and 9 means your answer either can be 31 or can be 39. So again we'll filter this, which one is correct. Again we'll use the digit sum method, right? And we're going to do digit sum method. Let's see. So 31 square can be 961, or 39 square can be 961, right? So next what we'll do, we will find the digit sum of 31 square first, which is 3 plus 1, 4. 4 square, which is 16. 16 will do 1 plus 6, which is 7, right? Digit sum is 7. Then we'll do the digit sum of 39 square, which is 9 plus 3, 12. 12 square, 144. 144 is 9. Digit sum is 9, right? We can color it. This is pink and this is black, okay. Now we'll find the digit sum of 961. See how much is coming? 9 plus 6 plus 1. So 9 plus 6 is 15 plus 1, 16. 16 is 1 plus 6, which is 7, which is matching with 31. You see, right? 31 is the correct answer. This answer is not valid. Means we'll cross this. So the perfect answer is 961. Means for 961, square root of 961 is 31. Or you can say even 31 square is equal to 961. Right? See how easy it is, right? So you can find the square root by this method very easily. Okay. Now I'm going to tell you the duplex method. See, duplex method is very important, and it's a bit tricky. Okay, let's try to understand how uh, we'll find that. Okay, so first of all, I'm telling you the importance of this method. This method is actually it is able to solve any kind of problem. Like just put whatever you if you want to write, and it can solve the sum. Okay, so I'm just writing some sums. Okay, see, I'm writing 5, 6, 6, 7. I want to find the square root of this number. Okay, so what we'll do, we'll write 5, 6, 6, 7 in this way. We'll do the first of all, our first step is we'll make the pair. No need to make the pair actually. Yeah, make the pair actually. We'll make the pair. Pairing is important here. So pairing is always from right to left, as we have seen. Now you see first pair is 56. So before 56 we'll find there's a number 59 from that table. Square root of 49 is 7, right? So that's 7. This 7 will come to here. Okay, here. And we'll double this 7. Double this 7 means 14. First step, first pair will search for the number, near number. Okay, nearby number whose perfect square is possible. Then we'll double this. Okay, doubling this this place, which is 14. I'll write the 14. Now 14 will become your divisor. Okay, see the next step. Okay, this 56 will be subtracted to this 49, which is 7. So I'll write here 7. Then this number will become 76. So I'll write 76. This 76 will be divided by 14, right? Then in this case quotient is 5, remainder is 6. So I'll write here quotient is 5, remainder is 6. Okay. Then after doing this we have 67, right? So you see the rule. Okay, in this case a bit rule is there. So what is the rule? After getting the second digit, which is 5, we'll put a line. Okay, and after this, from the second digit the duplexing starts. Means we'll do this 67 second 67 minus duplex of this number 5. Okay, so we'll do 67 minus duplex of 5 is 25. So we'll write 42. this 42 will be divided by this 14. 42 by 14. Quotient is 3, remainder is 0. Quotient is 3, remainder is 0. So right here 0. And you see in the question, after 7 there's nothing, right? So I'll put extra 0 here. So we have 0 0. Looks like a bit of flag method. So we'll do 0 0 minus duplex of. Now we'll take the duplex of both 53, 5 comma 3. So as we know, the duplex of 5 3 is 2 into 5 into 3, right? So 0 0 minus 2 into 5 into 3. So which is negative 30, right? So negative comes, according to the rule, we have to subtract q by q minus 1 and remainder by remainder plus divisor, means 14 here. Here in case of it will be 14, divisor is 14. So this 0 will become 14 and this 3 will become 2. Okay. So we can do the further step. We have 140 now. 140 minus duplex of 5 comma 2. Okay. So 140 minus duplex of 5 comma 2 means 2 into 5 into 2. So which is 140 minus 10 and 2, 20. So we have 120 divided by 14. So 120 divided by 14, quotient is 8, right? And remainder is 8 again, right? Okay. So write quotient as 8, remainder as 8. Okay. So now we will observe what else we have got. What are the numbers we have got? So we have got first digit, we have got 7, then we have got 5, then we have got 2, then we have got 8, right? So after getting this, right, what we'll do, we will see that how many number of digits are there in this question. So we have 4 digit, 5, 6, 6, 7, right? So if we have 4 digit, then this 4 will be divided by 2, which will be 2. So after 2 digit, okay, we'll put the decimal, means the decimal will be here, okay, 1 2 from the beginning. So the answer is 75.28. Okay, perfect answer, right? So this is how we do this duplex method. Okay. So basically this needs a practice actually. So I'm going to do another sum. Okay. So you can just copy the another sum. So suppose we are doing 4 5 7 8. Okay. So let 4 5 7 8 will make the pair of 2 digits. Pairing is always from right side. So we have 45. So we'll go number before 45, which is 36. So 36 square root is 6. We'll write 6 here. We'll double the 6, which is 12. Okay. Then we'll do 45 minus 36, which is 9. So 9 here. Then we have 97 divided by 12. So question is 8. Remainder is 1. Question is 8. Remainder is 1. So we have 18. Next step, 18 minus duplex of, after writing this line, we'll take the duplex of this 8. 18 minus duplex of 8, which is negative, because 18 minus 64 is negative number. So as it is negative, so this 8 will become 7 according to the rule, and at the same time this 1 will be added to this 12, which is 13. This 1 is changing to 13. So next step, 138 minus duplex of 7, which is 49, right? So 138 minus 49, which is 9 and 8. So we have 89 divided by 12. Quotient is 7, remainder is 5. Quotient is 7, remainder is 5. So after this 8, we don't have anything, so we'll put 0. So we have 50. 50 minus duplex of 7, 7. So 50 minus 7, 7 means 2, 7, 7. It's a huge number, so negative. So this 7 will become 6. Okay. And this 5 will become 5 plus 12, which is 17. So we'll do the last step. We have 170 minus duplex of 7, 6. 170 minus 84. So we have 16 and 70. 86 divided by 12. Quotient is 7, remainder is 2. Quotient is 7, remainder is 2. So just we'll note down the numbers. We have 6, we have 7, we have 6, and we have 7 again. So as I said, like in the previous example, we have to take the count of the digits, which is 4 here, 4 digits. So as it is 4 digits, 4 will be divided by 2, which is 2. Means the decimal will be after 2 digits, means 1 2. So here the answer is 67.67, right? So this method is very much means this method can do all kinds of sums, okay, and that too in quick session. Okay, the only thing is that you have to make a lot of practice actually. Okay, let's do one last sum. Okay, so I'm just doing 7. Let's take 3 digits actually, this time 3. So the number of 3 digits is 3. So in case of number of digit is 3, so we'll add 1 digit. We'll add 1. 3 plus 1 by 2. We'll divide by 2. So 3 plus 1 by 2 means 4 by 2. 4 by 2 means 2. So the decimal will be after 2 digit. Okay, so what I'll do, I'll make the pair. So 7 is there. Before 7 we have the number 4. So the square root of 4 is 2. We'll write here 2. We'll double this 4, double this 2, which is 4. Well, then they'll take 7 minus 4, which is 3. I'll write here 3. So we have 38. So we'll do 38 divided by this 4. This 4. Quotient is 9. Remainder is 2. Quotient is 9. Remainder is 2 here. So we have next, we can do 26 minus duplex of 9. So 26 minus duplex of 9 is 81. It's a negative number. So this 9 will become 8. And at the same time, this 2 will be added to this 4, which is 6. I'll write 6. Okay. So the next step, 66 minus duplex of 8, which is 66 minus 64. So 2, you see we are using duplexes. Okay, duplex of 1 digit is square, right? Square of that number. So duplex of 8 is 64. That's why I have written. So 2, this 2 will be divided by 4. Quotient is 0. Remainder is 2. Quotient is 0. Remainder is 2. After this 6 there is nothing, so I'll put 0. This is 20. So we'll do 20 minus duplex of 8 comma 0, which is 0. 20 minus 0 is 20. 20 by 4. Quotient is 5. Remainder is 0. Quotient is 5. Remainder is 0. So we'll again put 0. So we have 0 0 minus duplex of 805, 3 digit after this line. So this is huge negative. This 5 will become 4. This 0 will become 0 plus 4, which is 40. So we have 40 minus duplex of 8 comma 0 comma 4, which is 64, means negative again. This 4 will become 3. This 4 will become 4 plus 4, 8. So last step, 80 minus duplex of 8 comma 0 comma 3. So we have 80 minus 48. So we have 32 by 4, 8. That's it. So we have 2, 8, 0, 3, 8. Right? So we'll put the decimal after 2 digit. We have seen initially, right? So the answer is 28.038. You see how pure the answer is, right? Correct? Okay. So basically, this method, you have seen, right? We have seen some total 4-5 sums in this lesson. So we have finished with square and square root actually. Now our next agenda will be doing cubes and cube roots. Okay, in the next lessons we are going to see cubes, and after that we'll do the cube roots, right? And make sure that you finish all the practice sets which is given in this course, and along with that please write the test. If you write the test you can analyze your marks, okay, and you can see your speed also, okay, right? So we'll see in the next class. Bye bye.